Okay, so as you already mentioned, I work in Tenable and I do a little bit of security there. Some DevSecOps, some adversary emulation, things around that. But when we talk about DevSecOps, what is even DevSecOps? We know about DevOps, right? We'll do a little bit of refresher, but any ideas? What do you think? It's just do we just write some CI/CD pipelines, or do we just put security application into our CI/CD pipeline, and do we just and call it a day? Okay, fine. Maybe we run Snyk, or maybe we run something else on the pipeline, and to ensure that whatever code that we're pushing does not have any vulnerabilities. Is that all there is to it, or is there more to the story? Let's talk about it. But before we talk about DevSecOps, let's take a step back and talk a little bit about DevOps. It's just a refresher, and I'm sure a lot of people already know about it, but just refresh it just for the sake of this talk. Now, DevOps has to be agile. By agile, I mean you have to deploy quickly, and you have to keep your applications up and running all the time. Remember the blue-green talk. If something goes down, if you have the blue-green environment, you can have the green environment setup ready, or you can have multi-cloud. Maybe Azure is not working today, or maybe there was a tsunami in your Tokyo AWS region and something happened, so you decided to follow over to Google Cloud. And CI/CD, as you all know, you write some code, you push the code, and then it runs through a series of actions, and then it gets deployed to maybe Heroku or something else. Now, this was just a DevOps part, right? We deployed the application, we created the application, we made sure that everything was working all right, we made sure that everything is up and running all the time correctly. Now, when we talk about DevSecOps, when you put security in DevSecOps, we call it DevSecOps essentially. So the idea here is that when we want to move fast, we don't necessarily have to break things to move fast. You might have heard if we are not breaking things, we are not moving fast enough. We don't have to do it. We don't have to always wait for something to break down. For example, this runtime misconfiguration that we just had a few minutes ago in this talk, or the runtime misconfigurations that you can have in your infrastructure. So this talk is specifically going to deal with shifting left the security in your infrastructure. Let's move forward to this. Now, what are we really protecting against? I talked about infrastructure. That was a little bit of foreshadowing. But let's really think about it. What are we protecting against? Why do we want to shift left? Why do we want to stop the attacks before they even happen? Or why do we want to detect these misconfigurations before or pre-deployment? So, any guesses? Does anyone want to participate here? Why would we want to do this? What kind of attacks are we stopping? What major impact could it have if we do not detect these misconfigurations pre-deployment?
Complete down.
Yes, that's a possibility. Okay, so sorry. Someone said something about data corruption or something. Data leak. Okay, yes. Misconfigurations can lead to data leak. Or I think that is one of the demos that I can show you. But we'll come to this. Also, this will be oscillating between a little bit of presentation and a little bit of demo during this talk. So we can relate to what we're talking about. So, what are we really protecting against? And there is a really amazing case study. You all must have heard about it. We call them supply chain attacks. Something went wrong in one of the NPM packages. We downloaded maybe a Kafka package, or maybe some machine learning package from NPM. One of the modules inside of that package referred by them indirectly was vulnerable, or even worse, malicious. And now it affects our application and all of our customers. But wait a minute. This doesn't really happen, or does it? It does. You guys remember Sunburst? That really big attack at the end of 2020. 2020 was a great year, very adventurous. And at the end, we found this climax. So Sunburst is responsible for security of a lot of big companies. Google uses it, Microsoft uses it. They are big companies that they use it. And one of the services, the Orion Business Services, someone found the Orion service was poisoned. So someone found the signing key of Orion service, and they essentially poisoned Orion DLL file, and then they waited. It was a big APT attack, and billions of users were affected. Attacks like these could have been stopped if we had better static analysis capabilities. But today, we are not here to talk about applications. Because infrastructure security is not just for applications, or rather, DevSecOps is not just for applications. We should be worried about the underlying infrastructure, the cloud infrastructure, where these applications will be running. Now, in order to do static analysis, we should have some code, and that code is infrastructure as code. We have heard of CloudFormation, we have heard of Google Cloud Deployments, we have heard of Azure Resource Manager and Terraform and others. Let's see a little bit of example. So as you can see, this is some Terraform code. This example is for Azure, and this example is for Google. It's just some Terraform code. We will come back to this. So we're provisioning some services. We should not do this. This is a misconfigured service. We will see why it is wrong. Now, in order to detect misconfigurations, we have something called policy as code. The policy as code part runs on the infrastructure as code. Why do we do it? We do it to shift the security to the left. And when we shift it by shifting it to the left, essentially means when you're in the coding phase, when you have not deployed the services, that's the point where you're detecting all these misconfigurations. To detect them, we run policy as code on our infrastructure as code. I'll show you a sample policy as code. I made a small sample file here. Just these 14 lines of code will protect you. They will save you. So this code detects whether you are using the latest TLS version or not, because TLS 1.0 and 1.1 they both have known vulnerabilities. Now I'm not 100% aware of 1.2, but there's a chance that some 0-day must be out there in the wild. But then again, that's something we can always search on. Now, how do we really apply these policies? One of the options that we have is TerraScan. It's an open source software that we have. Now, TerraScan will scan your infrastructure as code files. What do we support? CloudFormation, ARM, Terraform, Kubernetes, Docker. Well, essentially a lot of infrastructure as code files. But today in our demo, we'll be scanning our Terraform files, and we'll also see our custom policies in action. As you can see, now this is some dummy key. Some keys not really keys, not even the correct format, the disk encryption key. But then again, this is a static analysis. I'm not actually going to run this Terraform file. Now TerraScan comes inbuilt with a lot of policies. There is one such policy that detects whether our Google compute drives are encrypted or not. Oh, it's supposed to be GCP. Sometimes demo doesn't go well. Maybe I should have shifted left and tested this before. Now we know that this vulnerability is here. Can we verify whether it's gone? We remove this comment, and now we have the disk encryption key. This is obviously not the correct encryption key. This is something random. We run the policy again, we don't have any violations anymore. Of course, you can write your own custom policies, and I'll show you one of the custom policies I've written. This is the one we talked about before, right? We're detecting a minimum TLS version requirement. It has to be 1.2. For this one, I'll be running it on Azure. Now, this is how my configuration looks like. I have the TLS version enforcement, but it is enforced to 1.1. This is not a good idea. Also, notice that HTTPS only traffic is not enabled. That is also another policy. You have the option to select your custom policy. So the custom policy says that you have to ensure that a TLS 1.2 version is enabled. This whole scenario that we are talking about, this whole shenanigan that I'm doing, it's just to demonstrate how we can shift left in infrastructure security. We have already done it in application security. We have a lot of static analysis tools. There are a lot of companies that are doing a really great job there. Infrastructure as code, policy as code, this is something new. We'll see how this can help your organization. Also, how students can contribute to different open source repositories. I'll be sharing a slide where I have all the links there. Also, just to verify, what if I change this? We don't have any violations anymore. Surprise, right? So, where can I use this TerraScan now? You can use it as a CLI tool, just like this, or you can use it in your GitHub Actions or whatever pipeline you have, Bitbucket, Azure DevOps, something else. It will work there. Or you can use it as an HTTP server. Now, what does it mean for customer companies? Companies who are trying to secure the infrastructure, find the misconfigurations before they make the deployment. Now, it's not just about TerraScan. Of course, there are other solutions out there, and it's just that I cannot recall them right now. You can search for them. Something like SAS tool for my infrastructure as code files. You'll find something, but because I know about TerraScan, I can talk about it. It means you can have custom policies. We already looked at them. You can have CI/CD pipelines. I could demo them. It's just that it will take more time. I don't want to go through all that length, and things may go wrong during that demo. I wanted to ensure that demo goes smoothly. Also, it will help you in catching infrastructure misconfigurations very early, which means faster and safer deployments. Which also means you won't have any vulnerabilities popping up after the fact. Then maybe you won't have to purchase Nessus. Now, what does it mean for the students or anyone else who wants to contribute to it? Doesn't have to be a student. You can be a professional and still contribute to it. We already talked about TerraScan. There's also KaiMonkey. KaiMonkey is just a repository of all the vulnerable resources, so you can add to the list. There's also, I think, AWS Goat. I'll have to check. It's just that I can't remember all these names. The ones I know for sure are here. You have Terraform, obviously. Terraform is open source, so you can contribute to Terraform. And then there's Terraform Flux Provider, Terraform Provider Flux. Now, Terraform Provider Flux, it's from some other company. I don't know I don't know what it fully does. I know for a fact that it helps in infrastructure as code. It's not directly related to policy as code, but it will help you in managing Terraform templates. It is obviously also open source, so you can also contribute to it. As for TerraScan, I can be your point of contact. I can help you through it. Now, questions, if you have any. Anything? Yes.
Okay. So what about these policies you scan for? Means you use the policies to scan your code, right?
Yes.
So how do we make sure that like we use correct policy to scan our code, or like do we need to create our own policies, or these are predefined policies?
We have a database. The database is not the correct term. We have a set of predefined policies. We have a lot of predefined policies that will work for most of the cases. But you can create custom policies if you want to.
Okay. And this is a SaaS tool, right?
Yes.
SaaS tool, right?
Yes.
Do you also have dash tool?
Our enterprise offering has a cloud scanner. So if you don't have Terraform or any infrastructure as code files, we'll just scan your cloud and we'll find the misconfigurations and will help in the, and will remediate them for you.
Okay. All these policies are publicly available because it's an open source software, right?
Yes, they are available. If you visit the Terrascan GitHub repository, or I can visit right now. I can show you.
Thank you.
So in package, we have this folder policies OPA Rego. Because we are using open policy agent, we are using we are using Rego for writing our policy as code. Of course, there are other options like Happy and there are others. I don't remember those. I know that there's Rego and there's Happy, but we use Rego here. Snick also uses Rego in case if you are wondering. So if you want to check out. These folders contain all the policies. If we go for maybe GCP, there is one for compute disk here. Very simple code. Also, if you do decide to buy the enterprise product, you will be able to see whatever policies are being applied, and you will be able to see the policy code just like you are able to see here. So same thing, we have a bunch of policies here. You don't have to define any new policies if you don't want to, but you can. Yes.
Are these policies, they are there built modules for CIS benchmarks and in your open API policies or open policies?
So, are there any policies related to CIS benchmarks in the TerraScan policy, predefined policies?
Yes, so while we do have policies related to the standard benchmarks like CIS, GDPR, and others, it's just that we have not mentioned those which policies related to which standard in TerraScan. It's related to the commercial product offering.
Okay, so it's in your enterprise offering, not on the open source.
The policies are there. It's just that you cannot see which specific policy conforms to which CIS benchmark. You'll have to correlate them. The content is the same. You will just have to download the CIS PDF file and you'll have to correlate them manually.
Okay, thank you.
Yes.
By default, we know that TLS 1.3 is the default version for TLS on GCP. Is Terraform smart enough that, like, while we are writing
Yeah, that's a really good question. I was expecting something similar. Now, Terraform and your cloud provider may not have a one-to-one parity with resources and the parameters in those resources. One of those parameters could be minimum TLS configuration. Now, Terraform may or may not conform to that updated parameter default value. As you mentioned, 1.3 is the default value for GCP. But if Terraform is keeping up, then the default value will be 1.3. If it is not keeping up for some reason, maybe someone forgot about it, whatever could be the reason, then the default value could be something else. That's where these policies come in. Because if you don't explicitly configure it, there will be some default value, and if you miss it, then there will be misconfigurations. Right. So yeah, any other questions on that? Yes.
I
I do have some old compatibility issues with a specific Terraform version. So will that Terrascan also mark as an obsolete and I am vulnerable, whereas I am already contested by this?
Okay, so Terrascan does not test for Terraform version as such. So, okay, so Terrascan has multiple ways through which you can it can essentially ingest your Terraform file. It can either be a TF state file or it can be the Terraform file itself. If it ingests a Terraform file, it runs a linear scan on it. It parses. We have a custom parser, and we also use the scale configuration to get all the data. At that moment, we don't check the Terraform version because we cannot. We get the objects out of the Terraform code directly. But if we have TF states, then we get the Terraform version. As of this moment, though, that Terraform version is not being checked because there are legitimate use cases where old Terraform versions are being used. For example, Terraform.